Now, okay, let's do this, you guys. We're at Unit 2. Are we? Yes, we are. Trigonometry. Oh my god. Have you seen this?
If I were to walk up to you on the street and say, you, please tell me what, no, I didn't want to write it that thick. Please tell me what sine of pi over 4 is. And obviously we're assuming we're dealing in radians. You either have that memorized or you would draw the unit circle right there. That's not the best looking unit circle, but you get the idea. You would go to pi over 4 radians, which is the same thing as 45 degrees. You would draw that unit radius out, and the sine is defined as the y-coordinate on the unit circle, so you would just want to know this x, which is just, but we just cared about the height, because the sine value, but what if someone else, let's say on another day, I come up to you and I say, you, please tell me what the arc sine of the square root of 2 over 2 is. What is the arc sine? And you're stumped. You're like, I know what the sine of an angle is, but this is some new trigonometric function that Sal has devised. And all you have to realize when they have this word arc in front of it, this is also sometimes referred to as the inverse sine. This could have just as easily been written as, what is the inverse sine of the square root of 2 over 2? All this is asking is, what angle would I have to take the sine of in order to get the value square root of 2 over 2? This is also asking, what angle would I have to take the sine of in order to get square root of 2 over 2? I could rewrite either of these statements. I could rewrite either of these statements as saying let me do it. I could rewrite either of these statements as saying sine of what is equal to the square root of 2 over 2. And this, I think, is a much easier question for you to answer. Sine of what is square root of 2 over 2? Well, I just figured out that the sine of pi over 4 is square root of 2 over 2. So in this case, I know that the sine of pi over 4 is equal to square root of 2 over 2. So my question mark is equal to pi over 4. Or I could have rewritten this as the arc sine of square root of 2 over 2 is equal to pi over 4. Now you might say, so just as a review, I'm giving you a value and I'm saying give me an angle that gives me, when I take the sine of that angle, that gives me that value. But you're like, hey Sal, look, let me go over here. You're like, look, pi over 2 worked, 45 degrees worked, but I could just keep adding 360 degrees, or I could keep just adding 2 pi, and all of those would work, because those would all get me to that same point on the unit circle, right? And you'd be correct. And so all of those values you would think would be valid answers for this, right? Because if you take the sine of any of those angles, you could just keep adding 360 degrees. If you take the sine of any of them, you would get square root of 2 over 2. And that's a problem. You can't have a function where if I take the function, where I can't have a function, f of x, where it maps to multiple values, right? Where it maps to pi over 4, or it maps to pi over 4 plus 2 pi, or pi over 4 plus 4 pi. So in order for this to be a valid function, in order for the inverse sine function to be valid, I have to restrict its range. And the way that we'll just restrict its range to the most natural place. So let's restrict its range. And actually, just as a side note, what's its domain restricted to? So if I'm taking the arc sine of something, so if I'm taking the arc sine of x, and I'm saying that that is equal to theta, what's the domain restricted to? What are the valid values of x? X could be equal to what? Well, if I take the sine of any angle, I can only get values between 1 and -1, right? So x is going to be greater than or equal to -1, and then less than or equal to 1. That's the domain. Now, in order to make this a valid function, I have to restrict the range, the possible values. I have to restrict the range. And for arcsine, the convention is to restrict it to the first and fourth quadrants, to restrict the possible angles to this area right here along the unit circle. So theta is restricted to being less than or equal to pi over 2, and then greater than or equal to minus pi over 2. So given that, we now understand what arcsine is. Let's do another problem. Let me clear out some space here. Let me do another arcsine. So let's say I were to ask you what the arcsine of minus square root of 3 over 2 is. Minus square root of 3 over 2. Now you might have that memorized. You say, oh, I immediately know that sine of x or sine of theta is square root of 3 over 2, and you'd be done. But I don't have that memorized. So let me just draw my unit circle. And when I'm dealing with arcsine, I just have to draw the first and fourth quadrants of my unit circle. That's the y-axis. That's my x-axis, x and y. And where am I? If the sine of something is minus square root of 3 over 2, that means the y-coordinate on the unit circle is minus square root of 3 over 2. So it means we are right about there. So this is minus square root of 3 over 2. This is where we are. Now what angle gives me that? What angle gives me that? Let's think about it a little bit. My y-coordinate is minus square root of 3 over 2. This is the angle. It's going to be a negative angle because we're going below the x-axis in the clockwise direction. And to figure out, let me just draw a little triangle. We know it's a negative angle. So when you see square root of 3 over 2, hopefully you recognize, hey, this is a 30, 60, 90 triangle. The square root of 3 over 2. This side is 1/2, and then of course this side is 1 because this is a unit circle. So it's 60 degrees at these. But if we're dealing in radians, that's not good enough. So we can multiply that times 100. Theta is equal to minus pi over 3 radians. And so we can say, we can now make the statements that the arcsine of minus square root of 3 over 2 is equal to minus pi over 3 radians. Or we could say the inverse sine of minus square root of 3 over 2 is equal to minus pi over 3 radians. And to confirm this, let me get a little calculator out. I put this in radian mode already. You can just check that. I'm trying to figure out the minus 1.04. So it's telling me that this is equal to minus 1.04 radians. So pi over 3 must be equal to 1.04. Let's see if I can confirm that. So if I were to write minus pi divided by 3, what do I get? I get the exact same value. So my calculator gave me the exact same value, but in the last video I showed you that if someone you're just saying the sine of what question mark, what angle is equal to x. We did this in the last video. So by the and the cosine of theta is the x value. And so if you draw a line, let me draw a little unit circle here. So if I have a unit circle like that, the origin, keep rewriting it, or the arc angle is this. The previous video, root of 2 over 2. Because this negative value, pi over 4 radians. So the arctangent of minus 1 is equal to minus pi over 4. Or the inverse tangent of minus 1 is also equal to minus pi over 4. Now, you could say, look, if I'm at minus pi over 4, that's there. That's fine. This gives me a value of minus 1 because the slope of this line is minus 1. But I could keep going around the unit circle. I could add 2 pi and map to inverse x is 2. x, what are all the different values? We're going to restrict it to the range. So let me write this down. Take on any value. But what about theta? Well, I just said it. Theta, you can only go from minus pi over 2 all the way to pi over 2. And you can't even include pi over 2 or minus pi over 2 because then you'd be vertical. So then you'd say so if I'm just dealing with vanilla tangent, not all of these over 2. And so if I restrict my range to this right here, and I exclude that point and that point, then I can only get one answer. When I say what tangent of what gives me a slope of -1, and that's the question I'm asking right there, there's only one answer, because if I keep this one falls out of it, and obviously as I go around and around, those fall out of that valid range for theta that I was giving you. And then, just to
Cosine.
example, we draw a solution to our problem. So let me make this triangle a little bit bigger. So that, actually, we just write that, and I could write that, cosine of 2 pi over 3 is equal to -1/2. This gives you that top, or the cosine of the cosine of that. Our cosine, it's pi. The cosine of the arc cosine of x is always going to be.
Okay. All angle measures in degrees whose sine is 1. Which is the principal value of sine -1, 1? Seriously? Do I get a calculator? So 90. Okay. Okay. 71. Is that a degree by? What does that mean? This is in radian. Arc cosine, which is the inverse cosine 110 in degrees. It's 4.3. Arctan. In degree in radian. 1 minute. Domain and range of inverse. I think this is important, so I'm gonna have to do some coding So, and this will be probably need some fucking time. So this will be it for today, you guys. See ya.